So we're going to start dealing with quadratic word problems, and today we are only going to look at questions that are dealing with gravity, so things either flying in the air or falling, or questions that deal with profit. So we're going to start with this question about the diver, and the greatest thing about this part of Unit 4 is everything is calculator active, so we'll be using Desmos for this. So I already have this equation in Desmos. So I'm going to come over here and look at the graph. So this is the graph of the diver. But since we're talking about t being time or x being time, nothing on this side of 0, nothing on the negative side is going to apply because time can't be negative. So what I'm going to do is I'm going to change my graph settings, and I can come in here and I can say that I don't want any x values that are less than 0. Well, I'm gonna move it over a little bit just so we have more room to see what happens at 0, but nothing on the left hand side of 0 matters to us. So this is the path that we care about. And I don't care about anything down here below 0 for y because h represents the height of the diver in feet above the water. So here the x-axis represents, in terms of y, this represents the water, and this is the diver's path into the water. So the first question they ask us is how high the diving board actually is above the water. So what I'm looking for here, since time is seconds for this dive, what I'm looking for is the y-intercept. So I'm going to go back to my graph. I don't really need my graph for this one based on what we did the other day with our equations, because this is my y-intercept, but I can click on the graph and my key feature points will come up. So the height of the diving board is the y value there, so this would be 40 feet. How long it takes the diver to reach his maximum height. So since it deals with maximum height, but I'm asking for the length of time, I need the x value from the vertex. So I'm going to come over here. I'm going to click on my parabola so that I can see my key feature points. And this tells me it takes 0.153 seconds for the diver to reach his maximum height. I'm going to just put 0.15 seconds because we typically don't think of time as to the thousandth of a second unless we're like in the Olympics or something. When the diver hits the pool, since the y being 0 would be the diver hitting the pool, that means I'm looking for my x-intercept. So I'm going to come back over here and I'm going to click on my parabola. So it takes 2.18 seconds for the diver to hit the pool. So I'm going to actually skip number 4 and go to number 5 for the moment. How long the diver spends descending. That means falling from his highest point. So I'm looking at the difference from the time to hit the pool, so the x-intercept value, minus the time that he got to his maximum height. So I'm going to put axis of symmetry because that's the x value. So I need to do 2.18 minus 0.15. and that will tell me how long he spends descending. So he fell for 2.03 seconds. The last question here is when the diver will have fallen 5 feet from the board. So what I'm looking at is, if this is the board here at 40 feet, 5 feet from the board is not down here at 5 feet above the pool. 5 feet from the board is up here when he's 5 feet below the board. So what I'm going to do is I'm actually going to create an equation that represents him being 5 feet below the board. It's going to be a y value. 5 feet below this, he's going to be 35 feet above the water. So this point right here tells me it takes him 0.88 seconds to fall to be 5 feet below the board. So that's everything to go with our diver question. And so we're going to switch over to looking at our profit question. So again, I'm looking at what these key features will mean in terms of this word problem. So if he's making this a free concert, this means that my X value, T is ticket price. This is where I should have X. So if he makes it free, that means my X value is 0. So I'm looking for my y-intercept. Well, I don't have to go to my graph to look at my y-intercept because it's this value right here at the end. Now, P, this output amount is in hundreds of dollars. So it's not just negative $4,500. It's that times 100. So really, if the promoter does not charge anything for this concert, they are losing $450,000. And I know that it's a loss of money because the output value is negative. So the ideal ticket price to make the most profit, since we're talking about most profit, I know I'm going to have to deal with my vertex, but I want my X value. So I'm going to come back over here. I'm going to get rid of our diver question. And I'm going to turn on our profit equation. I'm going to zoom out a whole bunch. Okay, so I want the most profit. This is where I would be making the most money. So my ideal ticket price would be $40 because that's the X value. Now the next question asks for the maximum profit the promoter can make. That's also coming out of my vertex, but now I want the Y value. So I'm going to grab that 300 because that's the Y value here, and I'm going to come back to my paper. Now remember, my P values or my profit values are in hundreds of dollars. This is not 300. This is 300 times 100. So their maximum profit is $30,000. If we want to look at what ticket prices we must charge between in order to make a profit, in order for me to make a profit, my p-value has to be bigger than 0. So my y-value has to be bigger than 0. So this tells me I need to know the x-intercept values because those are where my y-value is 0. So if I charge between those two prices, so if I charge between these two prices right here, it would be all of this part of the curve where I would be making profit because my y-value is bigger than 0. So I would need to charge between $30 and $50. Now I cannot include $30 and $50 because that would give me a profit of 0, and we want to make a profit. So between $30 and $50 is going to give us a profit. And the last question here, how much would they need to charge if they want to make $10,000? This is my profit value, but my output values in my equations have to be multiplied by 100 to get my actual profit. So here we were making $30,000, but my y value was 300. So here if I want to make $10,000, I'm looking for a y value of 100. So I'm going to come back to Desmos, and that's exactly what I'm going to type in, y equals 100. And now you can see these 2 points of intersection. That would give me an output value of 100, which means my profit is 10,000. So I could charge $31.84, or I could charge $48.17. So those are some examples of some profit and gravity word problems dealing with quadratic equations.